Hi. Alright, let's look at this question. Pause the video and try to solve the problem. It's a question involving normal distribution. So the net masses of box of sweet are normally distributed. So it means that the mass of a box of sweet are normally distributed, right? So the variance of the net masses is known to be 0.25. So first we know that the mass of the box of sweets, the x here refer to the mass of the box of sweet, which is normal distribution. It's a continuous random variable with normal distribution. So whereas the mean will be, we don't know the mean, right? Mean is not given, but the variance of the net mass will be the variance. This is your variance. So as you know that normal distribution is defined to be normal, right? Normal with the mean and the variance, right? And the variance. So since the production, right, followed by this question, they said that since the production process has changed, the mean is unknown, although the variance is believed to be unchanged. Means that the mean is the one changing here, so the variance is unchanged, right? It's believed to be unchanged. A check of box indicate that 20%, this is very important sentence here. A check of box, checking the box indicate that 20% have net mass greater than 16.5. Means that 20% have mass greater than 16.5, 16.5 gram. About indicate 20%, right? We having 20%. 20% is 20 divided by 100, which is 0.2, right? 20%. So find the mean mass of the box here. So they want to find the mean mass of the box. So before that, we have to standardize the score of x here. That we have to using the statistical table, right? So we have to standardize the score. So what I'm going to do now will be I'm going to standardize the score. So P, to standardize the score, the formula will be x, the z, standardize it. So into, I take the x minus with the mean divided by the standard deviation. So, okay, take the x here. Then the x, if I convert, it will become the z score, right? So it means that you have to take the x minus with the mean divided by the standard deviation, you're getting the score z. So now for this side also 16.5, you also have to minus the mean divided by the standard deviation, and this is your variance, right? Variance will be 0.25. So the standard deviation will be the square root of 0.25, right? Square root of 0.25, which is 0.2. So, alright, so I'm going to rewrite this in the form of k, easier for me, right? Easier for me to write. So I just let k, to be 16.5 minus with mean divided by the square root of 0.25 here. So, alright, based on my observation, this is your k, right? This is your k, which is 0.2. So you have to choose the right. This is already less than 0.5, right? It's easier. So there are two possibilities when I said pz more than k. Alright, so I give you, this is for revision, right? So more than k can be either, it must be always on the right, the area must be on the right, or it can be something that bigger than 0.5 here, right? Bigger than 0.5, right? Two of this distribution represent pz more than k, right? This is also pz more than k. This is also pz more than k. Why? On the right, right? But based on, we must look at this value here. We must look at this value. It's just 0.2, right? It's just 0.2. You know that half of the distribution will be only 0.5, right? It's only 0.5. This is just 0.2, right? So it's impossible to be this one, right? This is not the distribution. If this is the distribution, so this will be something greater than 0.5, right? So now I'm very sure that it will be something like this, all right? So we have more, we know that it's more than K, it's 0.2. So we just now, I already tell you that it's something on the right hand side here, but it's less than 0.5, right? It will be here. So the value of K will be on the positive side, right? Pz more than K will be 0.2. Now our statistical table is in the format of Pz more than K, right? The upper tail. So okay, now we can start finding the value 0.2. So 0.2, if you're using the table 3, you have to find the value of 0.2 here, right? You have to search where is the value of 0.2. If you're searching, you go one by one, okay, you start 0.209, and this is 206, 203, 0.2005, right? It's approximate to this, but it's not perfect, all right? It's not perfect. So, okay, just now, where is it? 0.2, right? All right, 0.2005. This is 0.1977. You should not round off, it becomes 0.2, right? If there is a possibility, if you want to round off, this is 0.2. If you round off, this is also round off, becomes 0.2. So you have some confusion. So you confuse which one to choose, right? So if this thing happen, you try to go for table. You're not using table 3, we're using table 4, right? At the end of the page of the statistical book for matriculation. So you look at the value here, 0.2, right? You find the alpha here. Is there any 0.2? Yes, 0.2. So the Z score correspond to 0.2 will be 8416. 0.8416 means that the value of K here is 0.8416 by using the table 4. Alright, table 4. So, and you want to find the value of mean, right? You want to find the value of mean. So you have to put it back the K to be 16.5 minus with the mean divided by the standard deviation, square of 0.25, 0.8416. So the value of mean, 16.5 minus mean will be 0.8416 multiply, right? Multiply with square root of 0.25, and your value of mean will be 16.5 minus 0.8416 multiplied with square root of 0.25, which finally will giving you the value of mean to be 16.079. So if you give in 2 decimal places, it will be 16.08 kg. 16.08 kg. Alright, so means I already find the mean value for this distribution. That's all for this video. Hope you understand.